reviewing yesterday, so we're going to talk about absolute value, and I'm kind of going to go off a little bit on a tangent for a second, and we'll try to explain what today's about. We're just solving absolute value with inequalities, right? So yesterday was pretty basic. We discovered that if I gave you the absolute value of x equals 3, you're going to, what two answers work here? You would know that x is 3, right? Or x is what? Right, okay. So we kind of learned a little trick that we would just, either one worked, right? But when it got a little fancy, we had to actually, couldn't do it in our head anymore. We had to actually write it out and solve. We'd say, okay, 2x plus 5 equals 3, 2x plus 5 equals negative 3, and we solved. Got two answers. Well, that's important, but just like we learned equations to begin with, like x plus 2 equals 5, so x is 3, one answer, versus a problem like this, I changed equal to greater than, right? And now I've got x greater than, so I went from one answer to lots of answers just by changing the equal to greater. Well, the same exact concept happens today. When you're dealing with absolute value, when you change your equal to a greater or a less, you open up your door to lots of different answers. Do you see what I mean? Okay, so just like we started yesterday with the real basic problem, I'm going to do the same with the real basic inequality. If I tell you that the absolute value of x is greater than or equal to 3, let's use our thought process for a second, and you tell me what answers make this true. What could I put in here? If I want x to be greater than 3, what would work? What are some numbers that are going to work? Wait, would 3 work?
Yes.
Okay, so 3 is going to work because 3 is bigger than 3. So if I'm going to, now build yourself a real quick number line here, just a basic one. So 3 works. Try 4. Would 4 work? Is 4 bigger than 3?
Yes.
Yeah. What about 5? Is 5 bigger than 3?
Yes.
Yes. Okay. So we're going to need all those numbers. 6 would work, 100 would work, 1,000 would work, correct? Lots of different answers. Are there any other answers you could think of that are going to work? Okay. 0 won't work, right? 0 is not bigger than 3. But would negative 3 work? Yeah. So on the other side of that, negative 3, because the absolute value of negative 3 is 3. Okay, what about negative 4? What's the absolute value of negative 4? 4. 4 works. You get what I'm saying? So I had all these numbers over here that worked, but I also have negative 3, negative 4, and all these answers over here also work. Kind of strange, right? Do you think that's an or an and situation? I think it's an or. Okay, these answers over here work, right? Or these answers over here work. Okay? So to jump from that, let me explain. Let's write down an inequality of what was true. Now this is where we're going to make the link for you. How, if I wrote these answers, I would say, okay, x is less than or equal to negative 3, right? That's these. Or, because it makes a jump. Remember me talking about when we wrote lines like this? You're this, you make a jump, there's your or, and then this array over here. You would write these answers as x is greater than or equal to 3. Make sense? Okay, now put your pencil down and just listen to the connection we're about to make. Yesterday, I said the absolute value of x, we wrote 3 and negative 3. Easy enough, that's all the problem. Okay? I realized we changed the equal to the inequality. But guess what? We don't change the way we wrote the problem. Okay? It would take forever to do them all in our head, right? So as they get fancier and fancier, we need to come up with an algorithm that works every time. An algorithm that works is exactly the same as yesterday. Watch, look what I did. I said x is, well, we'll go to this side first. I kept it the same. X is greater than 3, right? But when you flip an inequality, or when you change to negative, what do you have to do to the inequality? You have to flip it. So on the other side, I wrote, okay, I was greater than, I'm writing less than. See how I flipped the direction? I want to change it to negative. Just like before. I wrote x equals 3, x equals negative 3. So I left it alone, x is greater than 3. Perfect. But now I want negative 3 on the other side. In order to write negative 3, I can't use greater than anymore. I have to use a less than. Do you see? Okay, so either A, we can try to get them all in our head and figure out the answers, or B, we can just do the algorithm that works every time. Okay, which to me that's easier. So this is the answer to this. Now we have a slight problem. Not every problem that we do is greater than, correct? So sometimes instead of saying the absolute value of x is greater than 3, it might say the absolute value of x is less than or equal to 3. And my question to you now is, do you think that that's going to change what my answer looks like? Natural instinct for me would be like, no, you didn't do anything. But it actually does change what your answer looks like. Okay, so let me talk to you about it for a second. Think about this. Let me ask you some questions that are true here. Let's use our head. What works? Okay, can I start in the middle? Let's start at 0. Let's start right in the middle. Does 0 work? Is 0 less than 3?
Yeah.
Yes. Okay, go to 1. Is 1 less than 3? Yeah. Go to 2. Is 2 less than 3? Okay, how about 3?
Yeah.
Okay, can I go to 4?
No.
No. Okay, you agree. Now go the other direction. Will negative 1 work? Okay. Because 1 is less than 3, right? Is the absolute value. Will negative 2 work? Yeah. How about negative 3? How about negative 4? Okay. So on this problem, I had tons of numbers this way and tons of numbers this way. And it was a greater than. This was a less than, and I didn't create tons of numbers. What did I create, kind of? Like a little window of numbers, didn't it? It's a different type of answer, isn't it? Okay. Now, so let's draw a number line. And what's going to happen is when you have a less than symbol, that's what your number's going to look like. Put your 0 in, and I went all 1, 2, 3, right? Negative 1, negative 2, negative 3, and so forth. And these numbers is equal, so only this window of numbers worked. Agree? Okay, so if you take a look now at this, this is saying I want x to be greater than or equal to negative 3, and x to be less than or equal to 3. But it's not an or situation, it's an and. They call this a conjunction instead of disjunction. This is an and. Okay, now put your pencils down and listen again. Same as what we did yesterday. Look what I did. I'm going to drop the radical, and I'm going to keep it the way it was. X is less than 3. There it is. X is less than 3. Good to go. Now I need to create my other equation. Remember we always created 2? So go the other way, and I say x is what? We want negative 3 now, so we have to flip. X is greater than negative 3. Do you see how simple that is? Now, because these numbers are so easy, it's easy, but when we get harder and harder, we're going to apply the same exact concept. Now, there's one problem. When it's an or statement or a disjunction, we write our answer like this. Do we write an answer to a conjunction like this? No. That's numbers. X is between negative 3 and 3. That's how you write it. That's what's accepted. Okay? So just write it just like that. Between negative 3 and 3. Anytime it's a window. That's not anything new necessarily. So what I mean is this. Strange, huh? Exactly the same problem. All I did was change the direction of inequality, and it changed my answer. From the look of it. Okay? Alright, you ready for like this really cheesy way to help you remember it? Alright, so it's kind of sometimes confusing to check your work, and it really will help because if you're like me, every now and then when I divide by negative or whatever, I add wrong, I make mistakes, right? So I'm going to show you a way to help you fix that, okay? And it's really cheesy, but one of my kids showed me this, and I thought it was really cool. We have two situations going on. You either have a less than and equal to, or less than, right? And a greater than. Those are our two situations, less than and greater than, right? Okay? The less than situation created an and. So there's my less than, it created an and. My greater than created a what? What kind of situation? An or. Alright, so this is what they told me to remember. Okay, since the less than is an and, we'll call it land, right? And you'll get used to it really quick. Less than and land. Okay? Now this one's kind of cheesy too, but this is a greater than, right? So we're going to use greater than and or would make gore. So we have land and gore. Land and gore. Less than is and, greater than or, land and gore. It will really help. Watch. I'll show you when we do a problem or two. Alright, so here's the problem. Let's knock it out. Okay, just like yesterday, step one, isolate your absolute value. Is it isolated? In other words, is it all by itself on one side?
Yeah.
Absolutely. So then step two, we split it into two sections, right? It's either going to be greater than 5, or it's going to have 5 or negative 5. So when you do that part, you have 2x plus 5 is greater than 5, and you have 2x plus 5 is less than what? Negative 5. You can't switch the sign without flipping the direction of the inequality. Oh, it should be ones. I wonder why you're looking at me funny. There we go. I apologize. Better? Okay. Let's use our little trick. You can wait till later and figure out which way they go, but another way to look is here. If it's greater than, what's our little thing? Greater than or, right? So it's or. It's in an or situation. Okay. Solve for x. You're going to move the 1 over, which gives you 6, and divide by 3. That's one answer. I already know it's an or. So right, or. Gosh. Whoever's watching this video, I'm very sorry. I'm very thankful for all my kids in this class to help me with my mistakes. There we go. Is that better? It's 2. Okay, now go to the other side. And subtract 1 and divide by 2. We already decided it's an or. But just to make sure, we're going to graph it and look at our picture. And they should match. And you'll be really thankful later because when it gets to the last problems, they get harder. So let's graph. They're going to ask you to graph every problem anyways. And when you graph, do me a huge favor. Don't look at the two numbers and just graph it. Please read your answer and graph. You'll be less likely to make a mistake. So put 0 in the middle. I'm going to put my finger on this one, and it's at 2. So here I'm at 2, and it says x is greater than 2. So you're going to go that way. Then I'm going to look at this one and say x is less than negative 3. I'm going to go this way. Is that an or situation? Absolutely. So we did it right. All the numbers over here work, and all the numbers over here work. Okay, now go to the next one. Let's give it a shot. The absolute value is already alone, so what was always our first step? Set it equal to 27 and negative 27. But when you take the negative, you've got to flip the direction. So here's my two equations. Negative 3x is less than 27. Negative 3x is greater than negative 27. Flip the sign and flip the direction. Now use our little cheesy way to remember. Less than is what? Land and gore, right? So less than is and, yeah. All the other teachers, don't you find a trick? They'll be jealous when you find out it works. So, Tell your friends. Okay, now, solve for x on both. Be careful, I'm dividing by negative, so I gotta flip it again. It's confusing. And is answer is written differently, okay, which is what helps you. So you know I can't just box that answer. And the reason is because look at what it looks like when you graph it. I want numbers bigger than negative 9. So you're going to go this way with the one line. And I want numbers that are less than negative 9. So you got to go the other way with the other 9. That is not an or, right? How do you write the answer to that? And that's why knowing it's and just kind of makes life a little easier for you. When you write your and answers, it's smallest to biggest. Negative 9 is less than x is less than 9. In other words, I actually kind of like this method. It says it perfectly. Look, x is between negative 9 and 9. Right? Same here. X is between negative 9 and 9. Pretty easy, right? Go to the next one. Can I go ahead and dive in and set one side to 24 and one side to negative 24? No. Tell me why. Right. Not isolated. And you also can't decide and or either. Can't decide and or until it's completely isolated. Because if I divide it by a negative, I'm going to flip the direction, right? It's going to change my answer. Don't decide and or until it's all pretty and clean, right? Absolute value on one side, answer on the other. So move your 16 over, and you end up with 2x minus 4 is less than or equal to 8. Now you can decide. What's our little trick? Less than land. It's and. Now separate them out, right? One's an 8, one's a negative 8. 2x minus 4 is less than or equal to 8. 2x minus 4 is greater than or equal to negative 8. Another little trick, okay, I know some of you read less than as like an L. If you struggle reading, if I give you an inequality, I just say, hey guys, is that a less than or greater than? Or if I give you another one, less than or greater than. A trick on reading it without any difficulty is if you read a book, if you're scanning this way to read a book, and that's the way you read from left to right. So you read this direction, and as you approach it, what am I getting close to? The skinny end, right? So that's a less than. As I get closer to this, I'm reading it like a book. I'm getting closer to the big end, it's greater than. Just read it like a book. I'm going this way, less than, this way, greater than. That'll help you maybe. If you struggle reading the symbols. Add 4 to both sides, you get 12, so x is greater than or equal to 6. Add 4 to both sides on the other side, and x is negative 2. Remember, it's an and. So you cannot leave your answer like that. The and answer is between numbers. You graph it to make sure your and is correct and you didn't make a mistake with your signs. And here's the trick. Graphing it will do no good if you don't graph it for real. If I say, oh, it's and, I'm going to go to 6 and 2 and connect, won't help any. Have to actually look at your answers. Or graphing it isn't going to help you get the answer correct. Do what it says. Go to 6, check, I'm at 6. Read what you wrote. X is less than 6. Okay, no problem. There you go. Go to the next answer. X is greater than negative 2. Go to negative 2. Yep, I'm good. I've already had kids come up to me like, man, I'm glad you said that because I went one way, my picture didn't look right. Well, there's a problem. Okay? Now then your answer, least to greatest, negative 2 less than equal to x less than or equal to 6. All numbers between -2 and 6 make this problem up here true. You can plug in -2, you can plug in 0, you can plug in 1, you can plug in 1.5. Anything between this window works. Okay, what's your first step? I'm going to give you 1 minute. I can't decide and or until I get it by itself. So I'm going to divide everything by 3. Break it into 2 parts. Greater than is what? Or and so it's an or situation. And solve for x. Because it's an or, you can leave your answer like that. Because it's not in between. X is not between 2 numbers, is it? X is all one way and all the other. So it has to be written separately. Now draw your picture to make sure you did it right. Actually go check. Go to 4. X is greater than. Go to -3. X is less than. Good to go. Getting it? We're going to do 2 more kind of weird ones, and then 2 that are really strange. Okay, 4 left. I think you'll be okay with this one. It really wouldn't be my class, right, if you didn't throw in a fraction. What do I do first here? I can't decide and or yet. So what's my first step? Do what? Yes, always get rid of addition subtraction first. So move the 2 over first. You could multiply the entire thing by 6, but it's a lot of work. So move your 2 over. Now multiply everything by 6. Now we're at a point where you can determine and or. Greater than is 4, right? Okay. Break it up and solve. Draw your picture. And guys, some kids today I noticed will have tweak the decimals, whatever. No, we're just kind of looking, right? It's a positive number, so put it over here, leave it as 19 halves, and go to the right. Do you see what I'm saying? Yeah, I don't need, we're just checking, okay? This is a negative 17 halves, it's over here, and we're going to go to the left. And see, look, by me doing that just now, I caught a mistake, right? That if I wouldn't have to pay attention, I wouldn't have caught. If you will notice earlier, I forgot my equal to. So then when I went over here, wait, this one was equal and this one wasn't? Do you see how it helps? It really does help you find little mistakes. Questions on that one? There are 3 more. What's the first step? Excellent. Excellent. Add 3. This one's a little different than the problem before because that fraction is completely inside the radical. So you're just going to move the 3 over and then turn it into your 2 problems. Now you can decide and or. Less than is land, right? And just clean it up. Wouldn't surprise me if it was. Trying to hurry so you can have your quizzes. My mind is preoccupied. Okay, so move your 5 over. It's an and, so you can't write your answer this way. I'm going to go ahead and take care of my answer. This just says, hey guys, x is in the middle of negative 32 and 22. Now draw a picture. Do not use the box answer for your picture, right, when it's an and. Go up here and check. Here's my 0. Here's my 22. I want to go this way. Negative 32, I want to go the other way. Okay? Alright, if you have tuned me out or you understand, so you're doing homework, come back now. The next 2 are different. Okay? So here we go. They get stars and let me show you a new concept. Now, write down the problem, and it's going to look just like every other problem, which is why it's tricky. It isn't going to even look hard. Yet it gets a star. Doesn't look bad, correct? It's like every other problem we've done so far. In fact, it looks easier than the last 2. Okay? And it is easy. You just have to understand it. Right? What do I do first? Move the 16. And when that happens, what happens now? Right. Okay, yesterday when we talked about a negative, I'm going to put a little pink bucket over here for a second. If I told you this absolute value of x equals negative 3, what would you write as the answer? No solution. It's not necessarily the same in an inequality. It can be, but not necessarily. Watch, I'll show you what I'm talking about. Let's think about what this is telling us. What is the answer always to an absolute value? Over here. Positive or negative? Positive. Positive. So this side, this left side of the equation, no matter what number I put in, if I put in a negative 100, negative 100 times 4 is negative 400. What's the absolute value of negative 400? Positive. Still positive. No matter how negative you get, the answer to this is still positive. So on the left side, I've got positive answers, period. Right? Come on, guys, up here. I'm almost done. Okay, and I'm telling you positive answers, because it doesn't matter there, are greater than, what is this, a negative number or a positive number? It's a negative number. So put a bubble around there and think about that for a second. Are positive numbers bigger than negative numbers? Are you sure? Is there any world where every now and then a positive isn't bigger than a negative? What? No. Right? Never. Right? Positives are bigger than negatives, period. Right? 100 is bigger than -2. 1,000 is bigger than -1. Right? Positives are bigger than negatives. So what does it matter what I put in there? Every single number is what? Every number is going to work. I heard it. So what's the answer? R's. No matter what it is, right? The exact opposite of what happened earlier. Okay, and you can write yourself a note if you need to. Okay, you can say positive numbers are always bigger than negative. If you need that, that's fine. Whatever you need to help you remember this situation. How do you think my answer is going to be no solution? What's it going to take to do a problem to make it no solution instead of all real numbers?
Negative on less than.
Wait, I heard a couple of answers. Say it again, everybody. Yeah, you flip the what? Instead of a greater than symbol, what's going to make it no solution? A less than. You get down to everything simplified. If it was at less than, it's going to be a solution. Watch, I'll show you what I mean. Last problem. It gets a star too. I wrote it kind of crooked, sorry. Okay, what's my first step? Divide by what? A -6. Okay, so take care of that for me. And when you do that, you end up with the absolute value of x plus 3 is less than -5. Okay, right now alarm bells should go off in your head because I have an absolute value on one side all by itself and a negative on the other. Okay, so if it's an equal to, the answer is automatically no solution. But here it depends. Okay, now let's check. No matter what I do, what comes out of here will always be positive. Are positive less than negatives?
No.
That's never true. So therefore, in this situation, the answer is what? No solution. So let me ask you this. When you have an absolute value, a greater, and a negative, the answer is all real. If you have a absolute value, a less than, and a negative, the answer is no solution. Do you have to memorize that? Absolutely not. If you're not sure, check. Are positives bigger than negatives? Are positives less than negatives? Just ask yourself. Don't memorize it. Okay? Now you have time to work on your homework.